All right, welcome to another important lesson. This one is fundamental to how we understand what derivatives look like and how they in turn affect graphs. But this is a lesson that can go almost anywhere in the course. So forgive me if this should have been earlier or later, or if ideas seem to be leaking into other topics or pulling from the future. It's just how we think about pictures affects every part of this course. So let's just go ahead and think for a second. If I had a tangent line, or even just a line that looked like this, well, what could you say about the slope? In particular, is it positive or negative? And I hope you know the slope of this line is positive, and so if that was the tangent line, it would be positive. And if it was steeper, it would be more positive, it would be a bigger number. Similarly, if my tangent line looked like this, well, that has a negative slope, and so that's telling you that that derivative would be negative. And if it was steeper, well, it's more negative. Okay, well, so what might this look like? If I drew a graph that looked like this, it's going up the whole time, but also along the way, the tangent line always has a positive slope. And just happens to be getting steeper, so that derivative should be positive and getting more positive. And if I had maybe something that looks like this, well, it's always going down. It should always have a negative derivative, and so that derivative is negative. And in this case, it's actually getting closer to 0 as it flattens out, as that slope gets closer and closer to 0. And so this hopefully is not an entirely new idea to you, but we're going to dig a little deeper into how like the signs of derivatives and even second derivatives tell us about the shape of a graph, and how a quick look at a graph could tell you a whole lot about their derivatives. So we're going to start off with the increasing and decreasing test, and hopefully you can kind of figure this out just from our previous conversation. If f prime is greater than 0 on an interval, then what could you say about the graph? And our answer here is that f is also increasing on that interval. Right? If the slope of the tangent line is going up, is positive rather, then the graph must be going up. It must be increasing. And similarly, you can probably figure out what happens if f prime is less than 0 on the interval, then f must be decreasing. In fact, this might even be considered a reasonable definition in a lot of cases for what it means to be increasing or decreasing on an interval. Okay. Now, one of the joys and problems in working with math is that whenever we learn something, we have to think about all the different ways that you could be given information. So I could be given information as a graph, or maybe just as an algebraic expression or a function. And each of these is going to involve work that looks a little different. So as a quick example, here is a beautiful polynomial, and we want to know where is it increasing or decreasing. Maybe you already know how. What we're going to need to do here, to use our test anyway, is to just take the derivative and try to figure out where is it positive or negative. So I'm going to take the derivative real quick. Hopefully by about now you're already fast at taking the derivative of polynomials. I bring down that 4, multiply it by the 3. I bring down that 3, multiply it by the 4. That's convenient. I bring down that 2, multiply it by the 12. And then what happens to the 5? The 5 becomes a 0, and so I'm going to leave it off. Great. So I have this new function, this derivative function, and I want to know where is it 0. So hopefully in your pre-calculus brain, you have these inklings of knowing how to do that. Usually if you want to, if I want to know where it's positive or negative, I should say, then I should probably figure out where it's 0 to figure that out. Several ways to do this. I'm going to go ahead and start by just solving for when is it 0. Something we're going to be doing a lot in this course, taking derivatives and set it equal to 0. So first thing I'm going to do is factor this. Say this is 12x. Pull out that 12x and get an x squared minus 12x minus 2. Oh, sorry, it almost didn't pull out that 12x. There you go. Minus x minus 2. And you might be able to factor that real quick as well, a little bit further. This is 12x times, do you know how to factor that? It's going to be something with an x times something with an x. How about a minus 2 and a plus 1? That way they multiply to negative 2 and they add to negative 1. You could always use the quadratic formula if you need to figure out those roots as well. Okay, the joy of a factored form is that now I know that this is going to be 0. Is that f prime of x equals 0 when x equals, and we just look at our factors, 0, 2, or negative 1. Right, whatever would make any of those factors 0. All right, from here, still lots of ways to figure out where is it positive or negative. I always like a quick number line. So if this is right down here, my f prime, then at negative 1 at 0, at 0 at 0, and at 2 at 0, okay? And one way to figure out the rest real quick is just to plug in some numbers and see what happens. So for instance, if I were to plug in the number 1 into this whole thing up here, well, then I'm going to get a positive 12 times a negative 1 times a positive 2 is going to be a negative number. So I'm going to get negative numbers all in here. Because f is continuous, I really just need to check one number in the middle of any of these zeros to see where it's going to be positive or negative. If it's negative anywhere, it'll be negative the whole way through. If I plug in a 3, then it looks like I get a positive 36 times a positive 1 times a positive 4 is going to be some positive number. It's going to be positive all in this area. If I plugged in a negative 2, negative 24 times negative 4 times negative 1, negative times a negative times a negative is a negative. Going a little fast here. Maybe pause the video, see if you can figure out the negative a half. But in this case, it's going to follow this really nice pattern of minus, plus, and that's it. Lots of neat tricks on how to do these kinds of things fast. I'm not going to go over all of them. Hopefully you learned a couple in a pre-calculus course. But if you didn't, then just that little trick there is enough. Is figure out where it's undefined and figure out where it's a 0, and then just plug in numbers in between to decide if it's positive or negative. Okay, so what this is telling you is that if I actually was to graph this, I'm going from a negative value to a positive, back to through 0, negative, up through 0 here. It's telling you where the zeros and the negatives and the positives are. So a graphing calculator can help you do this quick as well. Great. So we figured out where it's positive and negative. Let's finish the job. We want to say that f is increasing. Exactly where we are positive here. So that's going to be from negative 1 to 0. And it's also going to be from 2 all the way up to infinity. And if I want to, I can even use this neat union sign to say it's those two together, both of them. And it's decreasing on, maybe you can figure this out, but it looks like the far left is going to be negative infinity to 1, union 0 to 2. All right, not too worried right now about your ability to use like unions and intersections, but it's a nice notation that can help you out if you want to write these things a little faster. Great. Notice that I did not include the endpoints. I did open parentheses here. Close brackets would mean include those endpoints, and usually we don't do that for increasing and decreasing. Usually it's an open interval, but there are people out there who do want to include those endpoints as well. We'll forgive them, but it's pretty uncommon. Great. So that is a quick example of of increasing and decreasing using derivatives. We'll catch up on another use in just a second.